A heat wave hit North America in 2021, and billions of mussels were cooked alive. Baby birds fell from overheated nests, but some species thrived. So when punishing heat happens, what decides who dies, who adapts, and who strangely wins in the animal world? That's what we're going to discuss here with marine ecology professor at the University of Victoria, Julia Baum. Julia, welcome into the program.
Thanks so much for having me, David.
So when people say heat wave, they think, ugh, sweaty. But in the animal world, heat waves can be really deadly. What are some of the negative things that can happen when we encounter a period of extreme heat?
Well, actually, really similar things to what people encounter. So the heat dome here in BC in 2021 actually was deadly for a lot of people. As I'm sure you know, the town of Lytton burnt to the ground. There were about 600 people that perished in that heat wave, and it was similarly stressful for animals. So everyone was feeling the heat out here. We found really widespread effects of the heat wave on animals as well as plants. Basically, any type of organism that couldn't get up and managed to escape it somehow really suffered.
Now, certain like mussels, for example, they just disappeared, decimated, if I'm not
Yeah.
correct. What other
Yes.
species really suffered?
All the other things living alongside the mussels on our coastline. So any what we call marine invertebrates, so mussels, barnacles, oysters, things like that, because they live on our rocky coastline, right? So they're basically sitting on this very exposed rocks. And if you think about, how much a parking lot, concrete in a parking lot heats up on a hot day, kind of similar thing. So in general, we had temperatures here where I am in Victoria around 35 to 40 degrees. But on those rocky coastlines, the temperatures were getting up to about 50 degrees Celsius. And those organisms, obviously, they're attached to the rocks. They couldn't move. And so they just baked by the millions, possibly up to billions.
Sounds delicious. Also sounds absolutely awful.
No, it was not delicious. It was my colleague, intertidal ecologist Chris Harley at UBC, was the one out there observing all of that and documenting it and taking photos and doing the estimates. And he talks really vividly about the stench of
Ugh.
all that dying meat. Basically, I think we eat mussels, but imagine leaving a billion mussels out on the coastline, baking and rotting in the sun. It was a pretty overwhelming smell, from what I gather.
All right, sounds like an ecological disaster and not delicious.
Not delicious.
There are some species that oddly thrived, and I don't want to paint this as a silver lining. It is not, but it's certainly a scientific curiosity, like sea lettuce, for example. What happened with various species that ended up oddly doing well in the heat?
Sure, sure. It is super weird, right? In the case of sea lettuce, which is really, most people have probably not heard of sea
Also
lettuce, but
sounds delicious, but probably
also
isn't.
it's definitely not. It's kind of it's like a green wet mop along our coastline here, right? It's like really spongy and absorbent, and anyone who goes for a walk along the beach on the west coast of British Columbia or the Pacific Northwest will have seen this. It's like a very bright green, spongy, wet mop type thing. But the reason that it did well is not so much that it, loved being baked in the sun, but what happened is all the other members of its community, so all the other seaweeds, which are brown seaweeds and red seaweeds and kelp, which are the type of seaweed that we really like, they all, kind of the same as the mussels, they just baked. They completely like bleached, dried out, baked, died. And then there was open real estate. And so the sea lettuce is a type of algae that is opportunistic. It's kind of like a weed and it can grow really fast. And so, it kind of saw this open real estate on the rocky coastline and just sprang up really quickly. And suddenly, instead of having this lush, biologically diverse seaweed community, we just had this green kind of spongy mop thing kind of all over the coastline, which is not what we want. So, it sounds like, oh, there were winners and losers. Well, maybe on balance, that's sort of okay. And that is absolutely not the case.
But it is curious that these species like did well as opposed to just universal doom during the heat. I know you're a marine
Sure,
ecologist. Maybe
sure,
it
right?
didn't
Yeah.
surprise you, but I'm kind of surprised by
Yeah.
that.
Yeah, I mean, I think they didn't, so it didn't necessarily do well during the heat wave, but in the month or two afterwards, it was able to increase and kind of capitalize on all the carnage that had happened around it during the heat wave. And for some other species, we didn't see massive declines in some species. So typically for mammals, big mammals and birds, we didn't find evidence that their populations had declined. But I would say that that's more so a case of we don't actually have really good data to know what happened to them. So for mammals, the only data that we have for mammals is what we call camera trap data. So that's basically where wildlife biologists have cameras set up kind of all throughout the landscape, and they take photos of whatever happens to be in front of the camera, every minute. And then you end up with tens of thousands of photos. And so what we know from that is that photos of large mammals like mountain goats and moose and caribou, and they declined. And so you can't say from that, oh, they were all dying and their population declined. Really, that just indicates a change in their activity level. So they probably just went into the forest and sought shade as any of us would, right? So it's a change in activity level, and kind of similar for birds. Basically, one of the only sources that we had for birds were acoustic recordings. So there were wildlife biologists who, not to do with the heat dome, but just were running these long-term studies where they had recorders set up and they record what they hear. And often what they're recording are songbirds, and they just found slight differences in the times of those songbirds. So what that tells us is that birds and mammals, they're doing something different, right? They're trying to escape the heat. So maybe they're out foraging in the open at the cooler times of day instead of the optimal time that they would normally do it. But we don't actually know whether or not a lot of them died, for example. And that kind of gets, the reason I'm making that point is that these heat waves just erupt very quickly without much warning, right? And so scientists don't have time to, plan a study and plan exactly how we're going to, collect the evidence for every type of species out there. We just had to, make do with what we had, which was by reaching out and talking to all sorts of scientists and say, did you happen to be out observing nature during this heat wave? And can you share data, and can we work together and try to figure this out?
So the impacts may well be worse than we
They
think.
could be way worse. Yeah.
On the plant side, were there areas where the plants actually absorbed more carbon from the environment during the heat wave? That seems kind of odd to me.
Yeah, so that might be a case of what we could legitimately call winners. So some of the plants, I think, on the landscape were winners in the sense that they were able to absorb more carbon. And the reason for that is because, well, the area that the heat dome affected was so massive, right? So it was over almost all of BC and into Alberta and Oregon and Washington. And so across that huge area, there are some areas that just happen to normally be a little bit cooler and wetter, right? And so those areas, if they heat up a bit, it can actually be good for them. It's like they're performing better than they would have normally. Whereas the areas that are normally hot and dry, that pushed them past their limit.
As extreme heat waves become sort of a new normal, unfortunately, are we heading towards ecosystems that have some kind of winners like this that reshuffle in positive ways in some sense? Or are we really just like barreling towards disaster here?
We're heading towards different ecosystems that maybe have different species in them as new species move in from further south. But we know that we can also be really proactive with our management. So we need to start putting things in place now to prepare for these heat waves, because we do know that they are coming and going to be more and more frequent moving forward.
Julia Baum is a marine ecology professor at the University of Victoria. Julia, I've enjoyed the chat. Thanks so much for being on the show.